Oh, that's not the same. I have to like put my brain.
Nice to see that they're taking
Yeah.
And if you're wondering what that means, that's my first slide. So you start there. Basically, it's just really fancy speak for we're going to have some sort of virtual camera, but we're going to mix that with some sort of real camera. So when I submitted this talk, I wasn't very far into this project. Pretty much this was all I had. But as you can see, that untextured quad is clipped into my table. So technically, this is mixed reality. Yeah. So we did it. Okay. This is not going to be a talk about Godot XR. That's the other one.
Yeah.
So there's not going to be any headsets or trackers involved. But yeah. So brief introduction. My name is Sarah. I go by badcop on the internet. I've been a Godot user for about 5 years. I mostly use it for game jams, and I'm also a Twitch streamer in the software and game dev category, which is kind of this weird small category on Twitch where people stream programming and game development. Most of the streams kind of look like this, where you have either a game engine, or you have some text editor, and then you have a very confused looking programmer in the corner rambling about something or other. You don't have a lot of context. And honestly, it's kind of boring. I don't know why anybody watches this, but they do. So I was kind of wondering recently, could we do something that's like more visually interesting if the coding is not really the focus of the stream anyways most of the time? Could we do something like Iron Man? How come when they do it, it looks so cool? The answer is, I don't know. I don't know how to do that. I don't like fancy visual effects stuff. But wait a minute. Games are kind of like visual effects. And I am a game developer. So maybe there's something there. So this is what I've been working on for the past like 2 months. It looks kind of like this right now. Whenever I switch windows, like if I always have it switches. And here's kind of like a trippy view of what the like scene looks like. This was a lot of work, and we're going to talk about some of the things that happened while I was working on this. So first of all, let's go back to the beginning. How do streamers stream? Pretty much everyone uses this software called OBS Studio. It does everything. It captures your desktop, it captures your camera, it composites everything together, it encodes that, it sends it to Twitch. There's also a ton of community plugins that make it do crazy things. And there's a bunch of software that integrates with it. The one problem is it's 2D. It doesn't do anything that's 3D. So I was kind of faced with a question. Do I want to put Godot inside of OBS, or do I want to put OBS inside of Godot? They both sounded kind of hard, but I decided that putting OBS's features into Godot sounded like the easier path. There's also scripting in OBS is not very fun. Lua scripting is the only built-in option. It's a very thin wrapper around their C API, so you're basically manually like freeing and allocating resources. And if you make one mistake, the whole thing crashes, which is good. The other option is you can control OBS with WebSockets, but then you're basically managing a bunch of external state, and we all know that's not fun. And using GDScript, I don't really have any complaints on that one. I kind of like it. Plus, I already know Godot, so it seems like an obvious choice for this. So, okay, what's the goal? I want to capture my camera and my desktop inside of Godot. I want to create some sort of 3D scene that looks interesting out of those elements. I want to render that in Godot. And then this part, for streaming and audio and all that, we're still going to use OBS because like that part seems to work pretty well. We don't need to reinvent everything, at least not right now. And the other goal I had was it only really needs to work on Windows because that's what I use. And if I try to include other operating systems, that's a lot of scope. But maybe someday. We'll see. Probably not. So the first step, we need to get the camera. we need some sort of live feed of a camera inside of Godot. Godot's camera server is really cool, but it doesn't work on Windows yet. There's a lot of talks about how to do that, but most of them involve bringing big dependencies into Godot. So they're probably never going to do that. We could use the Godot camera server extension, but it's like brand new and it doesn't really seem to have a lot of documentation yet. But it seems interesting and I'm going to keep an eye on it. Or we could already break our rules and cheat and just use OBS. So there's another cool plugin for Godot called Spout GD, which basically lets you do texture sharing. Texture sharing is you can basically, oh, that's the next slide. Texture sharing is basically this idea of there's already a texture on the GPU. Why not let another program also read that texture? So OBS would be writing the texture and Godot is just reading it. And Spout is a library that enables you to do this. It works with DirectX 11 and OpenGL, which is pretty cool. Unfortunately, Godot uses Vulkan and DX12. So Spout GD has to go on this little adventure where the texture goes all the way to the CPU, comes all the way back. And this is kind of slow. So I took it upon myself. I was like, well, I mean, looking at these two pictures, like, this doesn't seem hard to fix. We just have to do less work. Just do less steps. And then I read the Vulkan docs. And I came to the conclusion that I think one thing I learned is when you're doing these kinds of exploratory projects, you really need to like recognize when you're about to fall down a really deep rabbit hole and just not. They can be fun, but you may never finish the project. So okay, we're back into the project. We have our camera feed in Godot, and we need to do something kind of weird. We need to separate it into two layers. We need the foreground elements, we need the background elements. To do this, it's actually pretty simple. First, you take a picture of the background without yourself in it. Then you buy a green screen on Amazon. And then you just put those two together. And when you do that, it looks bad. Something about it just doesn't look right. And this was not something I expected, but it kind of makes sense. So why does this happen? Turns out real cameras aren't quite the same as virtual cameras. There's a bunch of random noise that subtly changes every frame. And if you take that away, it looks really weird. It looks like the camera froze, but only like the background with the camera is frozen, and it looks fake. And this is because of physics and stuff. Luckily, this is pretty easy to simulate. We can just write over that simulates the noise. And this part just makes a random number. This is shader speak for give me a random number, please. We take the existing texture, generate a little bit of randomness based on our UV coordinate, and then we add it to the texture and multiply it by a really small amount because we don't want it to actually like mess up the image. We just want it to kind of look like it's a live video. Okay, we're on to the next step. We have two layers. We've got the background and the foreground. Now we need to make the background 3D. So there's a lot of cool tools for this. You could like scan your room with your iPhone and like make a weird point cloud, and I don't know how any of that works. What I used is Blender and a tape measure. And I went around my room and I measured all the things and I made this little like block-out model of my apartment. But now we have a new problem. We've got this cool model, but we need to line it up with the camera. My first thought was, I could probably just eyeball it. It's like, it doesn't look that hard. But there's actually three things you need to get right. You need to get the position right, you need to get the rotation of camera right, and you need to get the FOV right. And if you tweak any of those values, it has impacts on the other ones. So it's actually very tricky to get it exact. Luckily, open source is really cool. Somebody made a tool. You just take a picture, you put some lines on it, and then it does a bunch of magic math that tells you what all the numbers should be. And this is a cool program called fSpy. So okay, we have it lined up. This is what it looks like in Blender. That's like the image we started from, and then a mesh on top of that. Now we need to apply the texture back to the mesh. So how do we do that? It seems like it might be kind of complicated because we need to like project it from the camera's view onto the model. But if we think backwards from what we want it to kind of just look like we're starting from the image we started with, or we're going back to that. So all we really need to do is take this line of a shader where we apply the texture based on its UVs, change that to a screen UV, and it's good. That's it. That's the whole. And then you get this cool thing where like it's 3D now. And as long as we look at it from exactly the right angle, it looks like a picture again. But we got some cool grid lines going on just to show that it's 3D now. So all that work, and we're back where we started. Great. Now we can start doing cool things. We can turn on depth of field blur, and it just kind of works. This surprised me. Most of the things I did so far didn't just work. So that was cool. The next thing I wanted to do is I wanted some way to capture windows inside of Godot. This is one of the things that OBS does that I want to port over. This was, don't be fooled by the fact that this is only one slide. This is like most of the work went into this QEA section. The code is really bad. It's Windows specific, and it's not GitHub if you care. Basically, you just pass it a window ID, and then it'll give you a texture inside of Godot that will update with the contents of the window that you captured. As long as you didn't try to capture some window that Windows deems uncapturable for some reason. Yeah, it's a good API. Microsoft for hosting that. So let's get back to the like fun visual problems and not into my garbage C++ code. I decided for some reason that it would look really cool if all the windows were transparent objects. I shouldn't have done that. Transparent objects cause a lot of pain. So what you're looking at here is basically I have two windows. One is kind of far away from the camera, so it's blurry from the depth of field. One of them is closer to the camera. And if we zoom in on where they're overlapping, you can see that the closer one is like overwriting the blur of the previous, or the background one. The reason this happens is that depth of field blur is just like done in a single pass at the end. So we go over the depth texture and we're like, okay, this part's really blurry because it's far away. But when you have things that are stacked on top of each other and they're see-through, that doesn't really work. So the real solution to this would be to do a pass for like every single transparent object, but that's not very reasonable. That would use a lot of resources. So we make a compromise and we do two passes. We do one that's kind of the background, one that's kind of the foreground, and we just kind of position it somewhere in the middle of the transition, call it good enough. I don't know how to use compositor effects, but I bet you could do this with compositor effects. I'm gonna go to AS Rollis talk tomorrow and learn how to do this with compositor effect. But for now, the way I'm doing this is it's just a sub viewport, and we render it once through one camera, and then we put that result on a quad and position that kind of in the middle of the depth of field place. And then we render again with a second camera. So that's what you're seeing in the bottom is just the scene tree and two sub viewports. And this is fine because I'm only streaming at 60 FPS, so like it works out. I also really wanted this effect. It's very subtle, but I'm very stubborn. I wanted this effect where it subtly glows in the points where like the windows are intersecting with the objects. And this is a pretty straightforward thing. The one on the right is just red to like exaggerate and show which part I'm talking about. And this is a pretty common effect. If you go on like GodotShaders.com, you can find a bunch of implementations of this, but it basically involves reading the depth texture, which is that scary looking grayscale texture on the right, and then doing some math and deciding how far the object you're currently rendering is from the object behind it. And if they're really close, then you add some color to make it glow. And this works great, except no, it doesn't, because nothing ever works. The reason this doesn't work, I don't have a screenshot for this one, because I forgot to take one before I got on my plate. But the problem is when the windows pass through each other, they think, oh, I'm really close to something. I should be fully white. So we need the windows to ignore the other windows. But we only have the one depth buffer that's got all the information in it. And since we want the windows to look kind of blurry, we need them to be in the depth buffer. So what do? 3 rendering passes. Really only use to run at 30 frames a unit. Come on. It's fine. Just one more sub viewport. So the way that this one works is we're only gonna draw the opaque geometry in the first pass. We're gonna take the depth of that first pass and save it to a sub viewport, because I don't know how to do compositor effects. And then we're gonna read that back later to get the glowy intersection information. There is one more tiny problem, and that's that when you do this trick of using a sub viewport instead of using compositor effects, you are kind of stuck using a texture that's got 8 bits for the red channel, 8 bits for the green channel, 8 bits for the blue channel. But that's not the way the depth buffer works. It's got more bits. So if we just like naively take the number that we get from the depth and put it into this texture, we're gonna lose a lot of information. But we do still have 24 bits to work with here. Oh, that's bad. So we have some code. This is another shader. It's not that scary. It looks kind of scary. Basically, all this does is you give it a float that's 32 bits and splits it into chunks and then puts it into a vec3. And then later, we just need to do the opposite of that. And you can kind of abuse the dot product to do the math for you, which is a neat trick. And yeah, now you have your depth texture and it looks something like that. But that's actually what you want. That's a good thing. That's not broken. Nobody's ever gonna see this. This is for the computer to read. So it works out. I still want to do a lot more things with this. I honestly thought I was gonna be a lot further 2 months in, but you know, rabbit holes be like they are. But I want to add, I really want to mess around with physics objects. Since we have the 3D geometry, we could like generate a collision mesh for the background. And in theory, it should just work. And I even think like shadows could work to some degree, but I'm not sure. I want to do more integrations with like Twitch itself so that people can redeem things and stuff happens. And I also want to mess around with hand tracking some more. I got hand tracking to work using MediaPipe, but I didn't do anything interesting with it. So this is just me like showing MediaPipe. But yeah, that's sort of it. Shout out to all these people who helped me, particularly Sade McMuffin on Twitch. I would just go into his chat late at night and be like, hey, you're good at shaders, right? And yeah, that's it. Does anyone have any questions?
Hey, can we just admire the end result?
Oh, sure. The question was, can we just admire the end result? I have no problem with that.
That's able.
Have you used this in a stream yet?
I did exactly one stream just to make sure it works. The problem is working on this on stream is very difficult because you can't like use it while also starting and stopping it a bunch because my GD extension has memory leaks. Yeah.
Was there any reception for it?
Yeah, people thought it was cool.
Have you solved the problem with Spout and OBS not always working right together?
And I solved the problem with Spout and OBS not always working right together. I think yes, because I stopped having that problem. There was a problem where just if you restarted the program a lot, like the Godot game, it's not really a game, but it would just suddenly stop working. I think the answer was literally just update Spout.
So, just based on the footage here, for one, yeah, looks awesome. But at the same time, you also see when there's that transition between the window coming in and out, it kind of passes through you
Yeah.
because I'm assuming the video of you there, because it's green screened out, it's kind of like transparent, right? Would it be possible to do like another depth buffer thing? Get you outlined while it comes through or something?
I thought about doing that. I messed around. I found this like machine learning model online that can create a depth buffer from just an image, but it doesn't run in real time on my computer. And it also like forgets how far away things were the last frame. So like if you hold your hand up, it's suddenly like relative perception of where you are is just somewhere else. But I thought that would be really neat. I don't know. I haven't figured out a way to do it with just a 2D cutout, but there's probably a way still.
So this looks really, really cool. Though one of the things that draws it, like you can see your eyes tracking over it, but as a result, you can see the whole problem of looking through a transparent whiteboard. But because you built the whole scene like out of these many parts, would it be possible, do you think, to like invert your own camera view and the whole 3D one so that your eyes are looking at the right spot on the terminal?
Are they looking in the wrong spot?
I mean, I could be wrong, but I think you look farther to the right when the
I mean, I
first
may just-
part to the left.
Because I kind of just positioned the thing in the world. I wanted to bias it a little bit more towards like being a normal rectangle on the screen because I want it to still be somewhat readable. And if it's too far like off to the side, nobody's gonna be able to read any of the text. But yeah, I probably could still fiddle with it more.
When you start up the stream, how is it aware of all the windows that you want to share?
That's another thing that's in the GE extension that I wrote. It's pretty much just polling windows to ask what are all the like windows that are open, and then I'm filtering out all the ones that are only on my main monitor, and that's kind of what I wanted it to be. But you could filter out like specific windows if you didn't want to capture like, I don't know, your bank.
Cool.
Cool. Well, thank you. This was a lot of fun.